Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. There are two statements. Statement 1, number of compounds among SO2, SO3, SF4, SF6 and H2S in which sulfur does not obey the octet rule is 3. Okay. Statement 2, among these sets in which all the molecules have one lone pair of electrons on the central atom is 1. Okay, so we have to determine which statement is true, which one is false. Okay, chapters involved is chemical bonding. Okay, so let's draw the Lewis dot structures of SO2, SO3, SF4, SF6 and H2S one by one. Okay, to draw the Lewis dot structure, count number of valence electrons of all the atoms in the molecule and distribute minimum 2 electrons between any two atoms. This is what you need to remember. Okay, for Lewis dot structure, count number of valence electrons of all atoms in the molecule and distribute minimum 2 electrons between any two atoms. Okay, for SO2, the total number of valence electron will be equal to 6 from each of them. So 6 plus 6 into 2, which is 18. So we have to distribute 18 electrons. So write SO and O and give minimum 2, 3, 4 and distribute the other electron pair. Try to complete the octet of every atom. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So the octet of sulfur is not complete. It has just 6 electrons. So therefore I will shift any one lone pair to make it a double bond. Okay. So yes. So showing the bond pairs of electron as lines, ultimately I will have S double bond O, single bond O. So this is the electron dot structure of SO2. Okay. So therefore S has 8 electrons around it. 4, 5, 6, 7, 8. Okay. So therefore it obeys octet rule. Cool. For SO3, total valence electron will be equal to again 6 for both the atoms. So 6 plus 6 into 3, since there are 3 oxygen atoms, which is equal to 24. And so write S and 3 oxygen and distribute minimum 2 between any two atoms. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so you can see the octet of S is not complete. So I will shift any one lone pair to make a multiple bond or a double bond. Okay, so therefore showing bond pairs of electron as lines, I will ultimately have S double bond O, single bond O, single bond O. Yeah, so this is the electron dot structure of SO3. So S has 8 electrons around it, 4, 5, 6, 7, 8. Okay, so therefore it obeys octet rule. Cool. Next we have to talk about SF4. Okay, so we know that S has 6 valence electrons. So I will write S 1, 2, 3, 4, 5, 6. Okay, and it shares 1 electron with each fluorine atom. So it shares 1 electron with each fluorine atom because fluorine can maximum form a single bond. So therefore, so you can see this is the electron that is given by fluorine. This is the electron given by fluorine. same here and same here. Okay, so it shares one electron with each fluorine atom. Okay, so therefore S has 10 electrons around it. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so therefore it does not obey octet rule. Okay, let's talk about SF6. So sulfur has 6 valence electron. So 1, 2, 3, 4, 5, 6. It shares one electron with each fluorine atom, and there are 6 fluorine atoms. Okay, so yeah, so S has 6 valence electron, 1, 2, 3, 4, 5, 6. It shares one electron with each fluorine atom. And there are total 6 fluorine, similar to the previous case. Okay, so therefore you can see S has 12 electrons around it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so therefore it does not obey octet rule. Next is H2S. So for H2S, we know that S has 6 valence electrons. So 1, 2, 3, 4, 5, 6. And it shares one electron with each hydrogen atom, since hydrogen can maximum form a single bond. Okay, so S has 1, 2, 3, 4, 5, 6 valence electron. One electron it shares with each hydrogen. Okay, and you can see S has 8 electrons around it. 2, 3, 4, 5, 6, 7, 8. Okay, so therefore it obeys octet rule. So therefore out of SO2, SO3, SF4, SF6 and H2S, SF4 and SF6, S does not obey octet rule. So therefore statement 1 says that the number of compounds in which sulfur does not obey the octet rule is 3. No, it is 2. Okay, so therefore statement 1 is false. Okay, so let's talk about statement 2. Let's draw the Lewis dot structure of all of them and check one by one. In H2O, O has 6 valence electron. It shares one electron with each hydrogen atom, and there are total 2 hydrogen atoms. Okay, so therefore the central atom, that is O, has 2 lone pairs, 1 and 2. So there are 2 lone pairs. Okay, next we have to talk about ClF3. So chlorine has 7 valence electron, 1, 2, 3, 4, 5, 6, 7. Okay, it shares one electron with each fluorine atom, and there are total 3 fluorine. Okay, so therefore the central atom has 2 lone pairs. Next, let's talk about SF4. So S has 6 valence electron, 1, 2, 3, 4, 5, 6. Okay, it shares one electron with each fluorine atom, and there are total 4 fluorine. Okay, so you can see the central atom has one lone pair. Okay, so central atom has one lone pair. So let's put a star mark here. Let's talk about NH3 next. So N has 5 valence electron, It shares one electron with each hydrogen atom. So now you can see the central atom has one lone pair. So let's put a star mark here. Okay. Then let's talk about BrF5. So Br has 7 valence electron. 3, 4, 5, 6, 7. Okay. And there are total 5 fluorine. So first one, second, third, fourth, and fifth. Okay. So you can see the central atom has one lone pair. So let's put a star mark here. And the next one is XeF4. Okay. So xenon has 8 valence electron. So 1, 2, 3, 4, 5, 6, 7, 8. And there are 4 fluorine atoms surrounding it. So it shares one electron with each fluorine atom. 1, 2, 3, 4. Okay. So therefore you can see the central atom has 2 lone pairs. Okay. So the set in which all the molecules have one lone pair of electron on central atom is NH3, BrF5, and SF4. Okay. So therefore um, statement 2, this is the pair I am talking about. This is the only pair where all the molecules have one lone pair of electron on the central atom. So therefore statement 2 is correct. Okay. So the final answer is statement 1 is false and statement 2 is true. Okay. Thank you.